Okay, let's talk about FeatureCAM, and we're going to talk specifically about feature-based machining, and in this video we'll do 2.5D milling features. So what is FeatureCAM? Well, FeatureCAM is a feature-based software where when we create toolpaths, or we want to create toolpaths, we create what is called a feature. And that can be done from simple geometry that you import, such as a DXF or a DWG, or it can be CAD that you draw. So FeatureCAM has CAD tools in here if you need to make your part from a print, or even better, if you have a solid model, you can also use those to create features. So a feature is a shape containing all the operations necessary to machine it. So as you can see here, FeatureCAM is also ribbon based. So as we have different functions that we're after, the ribbon at the top changes. And then we have a guide of your workflow here called steps. And basically you can walk through this and program your parts. You don't necessarily have to use the steps, but this is a good way to kind of know what the workflow is. So the first thing we would do is identify our stock. This particular stock is already created, and you can see the size of it. It's from a block. And you can also see a material assigned to it. Now this is super important because this covers the feeds and speeds for what you're going to create. So FeatureCAM comes with many pre-installed materials that will handle the feeds and speeds for you. So let's take a look at the one we have right now. So stainless 303. So how does this actually work? If I click on the feed and speed table right here, this is a pre-populated and fully customizable data table for you to enter your surface feet per minute values and your inch per tooth values. So depending on what type of machining you're doing, milling, drilling, turning, etc., you will have different parameters that you would enter. It also matters on your tool type. So if you have a high-speed steel versus a carbide, etc., you're going to have different surface feet per minute and inch per tooth values potentially. So as you can see right here, if I'm doing any milling and I'm doing profile machining, so that would be like pockets, open side cuts, boss features going around something, things like that. So contour might be a term you're familiar with. So those type of shapes, you would have a surface feet per minute for the roughing and the finishing, and then the corresponding inch per tooth values for rough and finish. Same thing for slotting and any face milling. And then there is a plunge here. This is actually a roughing strategy in surface milling for really deep cavities. So that is if you use that strategy. And then of course you have drilling things. You have surface feet per minute and inch per rev here, as you would in turning, inch per rev as well. So depending on what you're machining, you're going to get different values. So we'll go ahead and program this part using this particular set of settings for the stainless 303, and then I'll change the material later and we'll see how the feeds and speeds automatically update. Okay, so how do we create features? Well, in this particular file, I have one setup in here, and what I want to do is try to extract features. Now, if I were to look at the workflow, the next thing would be geometry. Well, my solid model is my geometry, so I don't necessarily need to draw anything here. But if I was working from a print, that would be where you go to start drawing things in. A curve is basically geometry that's linked together, and you make the shape. So we'll see when I do program this, we'll get a few curves and how that applies. Okay, so FeatureCAM also does have some surface creation and modification tools, as well as some solid modeling. So you can do it if you don't have another option for solid modeling, you can use that, but if you're more familiar with another product like Fusion 360 or Inventor or something like that, then you would just go ahead and use those, and then you can import them in. And that's what this is a solid model made in another software and imported into FeatureCAM. Okay, so after that, you'll notice I have an automatic feature recognition option. And so this is where we have a solid model when we want to extract features off of it. So this is the particular part that I'm going to use for this example, and we're going to have to flip it over and do some machining on the other side. Okay, so we'll get multiple setups in one document, and we'll talk about that. So I identify my solid Since there's only one, it automatically selects it. And then I have a few parameters, like I want to face it, put my holes in patterns, anything over an inch as far as a cylinder goes, let's mill that. Anything under, we'll treat it as a hole feature. Okay. A few other random settings I'm not going to get into for now. And then if you have a valid solid, things should work really well. So when I press next, you'll see that FeatureCAM recognizes setup one. If I had more than one setup, then it would notice both of those and give me the option to program one or both, or three if I have three, whatever there is. But since I have just the one, that's all we're seeing here. When I press next, then I will see all the features that the software recognized pretty much in an instant. So one of the settings I had was to face the part. So it is going to face it for me. Just so you're fully aware, the setup is down on top of the model and I have material up above to machine off with my facing operation. So we'll look at that in a bit. And then I've got a bunch of holes. And in fact, as we go through here, we have a dozen or so. In fact, we have 13 holes. And then we have a milling feature going around the outside of the part. Another one to do these slots. In fact, we have 4 more. So we have a total of 5 milling features. So I'm going to go ahead and accept these and press finish. But before I do that, let me draw your attention over here to setup one. So this is the part view versus the steps. So in the toolbox, we have multiple ways to look at things. And when you want to see the things that are being created, you will look at your part view. And if you want to go adjust things, a lot of times you'll work from the part view. I want you to notice there are no curves currently in here. If there were, there'd be a plus sign right here. So next to curves, there's nothing. These 5 features are going to require curves. So as soon as I hit finish, we see all the features that were created. I accepted all these from the preview of the AFR, and here are some curves. Okay, so curves 1 through 5. Okay, so those correspond to those milling features. Okay, but the real magic happens over on the right side. Over on the right side, you'll see that I already have all the operations over here. So each particular feature, for example, a hole feature, will have a spot drill operation and a drilling operation. So multiple operations in the feature. Okay. It's also selected the tools based on the tool crib that I have active. And right now it looks like I have a metric tool crib active because I have the letter M next to all my tools. I'll show you how to switch the tool crib and how FeatureCAM will just automatically update here in just a moment. I also have feeds and speeds. Now remember, this is based on 303, stainless 303, and whatever those values were coming from that table. So to change the tool crib, I want to get to inch tooling. So this part, we're doing it in inch, and I want to do it some inch tooling. So what I can do is down at the bottom, in the bottom right corner, I can select a different tool crib, and I'm going to select this one called Basic. And now if you look at the tools, all those are pretty standard as far as the type of inch value tooling in here. Okay. So I have a couple warnings I want to be aware of. So it says, hey, this tool is greater than the max tool diameter of 1/18, which is actually 3 millimeters, just so you know. It said curve may not be cut cleanly. All right, so we'll address this in a bit, but I'm also looking for any exclamation points that might appear. And an exclamation point is something I have to definitely solve. This warning is basically saying, hey, just so you know, I may not be able to clean this up because the tool's too big. So you might wonder, why didn't FeatureCAM, since it picked tools, just pick something smaller? Well, it is following a list of settings that we call machining attributes. Those machining attributes come from a configuration when we load a file. So where would we find things like that? So if I go to features and manufacturing, under here, there's a lot of stuff, and this is how we can deal with our feed and speed table. If we want to make some modifications, that's another way to get in here. This is how we can switch our tool crib and add tools to a crib, etc. Right here in machining configurations and attributes, I can make changes. A machining configuration is basically a set of defaults that you want for step overs, depth of cuts, pecking values on your drilling cycles, what type of cycles you want to use, things like that. All basically the overall settings you want to have loaded into a new file. Okay. Right now I'm using the FeatureCAM defaults, which is what's called my configuration. So everything's pretty aggressive. We'll talk about a few of the settings in a little bit. But as you can imagine, you might have different settings for 17.4 precipitation hardened versus aluminum. And you might have different settings from those two to between them and plastic, and then another stainless or Inconel. So you can have configurations for any scenario that you need. So we'll look at a few of those settings in a bit, but I am using just the FeatureCAM defaults. So those are the active attributes in a file. Okay, so one of the things that I want to kind of point out is in here we have a step over. This is the depth of cut. We're doing full tool diameter as the depth of cut. Now in 17.4 or stainless 303, that might be super aggressive. So I would modify these settings, or I should have just loaded the configuration that corresponds to what I want. Okay, so that's where those are, and this is your step over. These are just examples of settings you might change. Okay, so if I were to look in one of these features, I'm going to look at this pattern one, hole one. I'm going to go ahead and open this up, and you'll notice that the diameter on this is 118 and 1/10. That is the inch conversion from 3 millimeters. Okay, you'll notice that the drill that it picked was a 120. So there's a tolerance built in here. So these are just examples of how this feature-based works, right? So if I were to go look at the machining attributes and go to tool selection, we would see that there's a 2 thou diameter tolerance in there. Now, if I decrease that to 1 thou on each of those areas here that has the 3 millimeter, now I've got an error with an exclamation point, and it says basically, hey, I'm looking for a tool that has a length of 3 millimeters because that's a very shallow hole, or a tool diameter of that 118 and 1/10 within plus or minus 1 thou. And since 120 is outside of that range, it didn't pick it. So apparently in my tool crib, I do not have that. But when I use the default right here, you'll see that it automatically just will update. And that's usually what I run that at. Obviously, you need to check and make sure that's not out of tolerance, or you need to go get a 3 millimeter and add it to your tool crib, right? And then you can select it on your own if necessary, if the software doesn't. Okay, so it's done a lot of the heavy lifting, right? We have a few things we kind of need to talk about here. So this is the tool diameter, 1/8 of an inch is too big to cut this. So there is something limiting that, and that's actually found in the same area in my settings, and that is called multiple roughing tools. Okay, and so you'll notice that there are a set of rules here, and basically my rule is to use a 1/2 inch end mill. Use a 1/2 inch end mill where possible, but the reason that it was able to pick this 1/8 inch tool on these areas where I have smaller radii on the machining is because I have a setting that says, hey, automatically select a tool that fits the smallest radius of the contour that we're trying to machine, right? So it's going to try to do the bulk of that with the 1/2 inch, and then it will grab a smaller tool. And you say, well, why didn't it go smaller? Pick something smaller than the 118. Well, there's a limit right here. It says the minimum tool diameter that FeatureCAM can automatically choose for roughing is this. So if I shrink this down to say like 0938, something like that, something smaller, or a 16th or whatever number you want, you're okay with roughing. As soon as I hit OK, watch these update. I'll have to scroll down over here, and we'll see that we got the 093 in those areas where it needed a smaller tool. So what you're seeing is FeatureCAM is really dynamic. One, I programmed it. I had a metric tool crib active. It picked metric tools out of there. Then I switched it to an inch crib. Everything switched to the inch crib that I had, the basic crib that has inch tooling. And then I just showed you a few parameters and how they affect what tools are selected. So as you can see, FeatureCAM is doing a ton of work for you. That's the whole point of feature-based. Okay, so we have simulation would be one of the things we need to do next to verify. You'll notice in the bottom right down here, hopefully you can see my little circle, there's NC code tab, and we want to see that. That'll be our code at the end. But right now I haven't generated any code because I don't have a simulation completed. So I'm going to run what's called a center line. I'll just run this slow for the first time. We'll see the tool, and the color green means rapid. The other colors you're seeing are the feed rate moves, so the moves at whatever specified feed rate. I want to draw your attention to the right-hand side while this is running as well. This yellow arrow is moving down through the list and showing us exactly where we are. And here we can see we're cutting the perimeter, and it was a 1/2-inch tool. And now we're using a smaller one, and that was picking out those corners. That was the 093 tool that I said you can go down to that. And so it's getting the tighter areas, tighter radii. Okay, so we work down the list, we keep going, and as soon as we're done with simulation, you're going to notice two things. Now I have a new set of warning triangles. These basically are warnings, and what this is saying is I hover over it, it says no toolpath was generated. So for that operation, for side 2, rough pass 1, so if you look to the right, it says side 2, rough pass 1, you'll see that it has that warning triangle. When I hover over these, they say no toolpath generated. That's the 1/2-inch end mill. If you remember from the machining attributes, I said, hey, let's use a 1/2-inch. So it tried to, but in that case, that particular feature, whatever that is, so we've got side 1, which is cutting around the whole perimeter. We're okay on some of these, right? And then on side 2 and elsewhere, we were getting that warning saying, hey, the tool's too big. So these slots aren't that big, right? So if I were to do a measurement on these, I could just throw a simple dimension on here to look. There's multiple ways to check things in FeatureCAM. But I can see that's got a 165 width on that slot. So a 1/2-inch isn't going to work. So that's where we were getting the warning. So it literally just skipped those operations. Let's go ahead and watch this in 3D, okay, and watch the arrow. Now 3D will actually help us for any collisions we might have. I don't expect any on this particular part, but if we were rapiding a tool into an area where we haven't machined already, or if we rub the shank or hit the holder, as you can see there's a holder displayed here, those would be collisions. There are those warning triangles again. It literally jumped past those. It's not going to output these in the code, right? So if I look, speaking of code, now that I have a completed simulation, here's NC code based on whatever post processor I have active. Now right now I have just a generic Akuma post processor, and you'll notice that I have H1s and stuff for that. So in my setup, I have number 1. So Akuma uses H1, H2, etc. for the fixture offsets. Okay, so when I make a new one, we'll see how that works. Now, if I were to want to run another machine, let's talk about what FeatureCAM actually offers. So with your installation of the software, if I were to browse into the C drive and program files, I would find the installation for FeatureCAM, and we would find this post folder right here, and we have some mill posts, turn posts, and wire EDM posts that come with the software. Now, not every post does. The more complicated ones like 4 and 5 axis or advanced turn mill machines, things like that, are going to need to be purchased per Autodesk's requirements. So if I go to the milling folder, for example, you'll see I have a 3 and 5 axis folder. I just want you to see that this 5 axis folder just has an apt post in here, just an example thing. Nothing that would really run your particular machine. Okay, so if I look in the 3 axis folder, you'll see a whole bunch of posts. These all come with the standard installation. So right now I'm using the Akuma. You can see there's Haas posts in here. There are some Morisiki, Mazak, even Mach 3 if you're running that on a router or something. You got all kinds of different ones. And then there are even some folders for just FANUC control, for like your robo drills, a standard FANUC post, etc. And just to hit on this, let's look in the turning folder while we're here, and you can see there are a bunch of posts for different lathes as well. All right, so I'm going to stick with my Akuma post. We see that the code has a need to be regenerated. That's because I was flipping around in the post, and I need to just resimulate. As soon as I resimulate, there's my NC code. Okay, so let's talk about those features that had the need for just smaller tooling. So it picked, if I look at side 2, that's one of these. You can see I have 2 rough passes. This is the 1/2 inch end mill. This is whatever it picked, the 125 in here. So, and then the finished pass will use that same 125 or 1/8 inch. So maybe I just want to remove the operation. This is just an example of how you could do that. Here's the setting coming from the machining attributes saying use the 1/2 inch, and then the (0) means automatically find something smaller, in this case 1/8 inch, that will clean things up. And then of course we saw that if we don't have a tool small enough, it'll give us a warning and say, hey, we can't clean it all up, right? Okay, so I could just say, hey, you know what? I'm going to go ahead and use the 125 here. So I'll just hit set and hit apply, and you'll see that operation just disappears, the first rough pass, and we're just using an 1/8 inch tool. So FeatureCAM's picking from it. You'll notice here as well, there are multiple 1/8 inch tools. Some are longer, some are stubby. FeatureCAM's going to pick also the shortest tool for rigidity, right? So if we look at our cutter length, that's the category for our flute length. Cutter length is how that's called. You see some of these are longer, and we're only going a total of 3 millimeters or 118 deep on this part. And so therefore it picked the shortest tool. Okay, so FeatureCAM's automation winning again, right? Okay, so as you can see, this was a really easy part to program from here. We got all these operations, we got NC code and whatever, but now we need to flip the part over. So I'm going to just go ahead and roll this around just so we can get a look. And I'm going to make what's called a new setup up here. And I'm going to give it, either give it a name or accept setup 2. That's fine. And you notice it incremented from 1 to 2. So that'll be the next offset I use in the controller on the Cincinnati. That'll be the fixture offset I dial in. You can make it whatever you want. You have the option. Okay, now I need to align it on here. What I want to do is either pick a corner on the stock on the bottom. So as you can see, I click bottom and this moved. I could put it here. I need to think about how I'm going to flip the part over. So, you know, here's my part right here. I want to just flip it this way. My X needs to point accordingly. That's great. Now I could put it here. I could stick it on any corner. I can even place it right in the middle, or I could place it over something that I already have, right? So let's say, for example, just as an example, I want to put 0 over this hole in the center of this bowl hole. I can do that by hitting the pick location and snapping onto the cylinder center. And if I go here and look, we'll see we're right down on the model and centered over the hole. So I just need to make sure that hole's drilled through deep enough because I have material I have to face off, right? So that would be an example of how you would locate it there. So now I have that. So I'm going to go find that hole feature, which is right here. You can see as I hover over on the left side, the green lights up in the graphics window. And I know that my stock is a 1/4 inch thick. So I'm going to take this hole, the through, make it a 1/4 inch and have it do a breakthrough so it goes a little bit deeper. You can see the feature update right on the screen in real time, right? And we got that. So there, but I also had located this down below, so I don't necessarily need that 3 millimeters. So just find whatever it is, or 250, whatever it is. I'll just put 200, hit apply. You know, take a look at it here, see if that looks right. Okay, sounds great. Okay, so now what I want to do here is I could run AFR on here again. So if I run AFR again, you'll see that FeatureCAM recognizes, oh, you have 2 setups. Well, I've already done this, so I could do AFR on this. If I do, it's going to see every feature that breaks through and features from this side, it's going to want to program. So all these slots and all these holes are already done. So I wouldn't, in this case, accept those. The perimeter of the part's also done. I did that in setup 1. So I may not want to use AFR on an example like this because I only need a couple things. And what I need to do is basically cut out this channel. I need to cut this flat to this wall. There's another channel here and one here, plus face off the part. So I don't really need AFR in this case. So there is another method on how you can program. You can just program from dimensions. So a face feature, for example, I just need to give it dimensions. So it says from dimensions. All these features require curves, and these are taking features and doing something with them, such as like patterning, for example. Okay, like patterning a hole or something. Okay, so I'm just going to face it. I'm going to face it to 0. My setup is right down here on this. That is my where I want to face to. So I'm facing to 0. And then you'll see FeatureCAM automatically picks up the thickness of what is left. So we have 81 thou left in here to machine off. Now that number comes in handy if I want to rough that off. If I don't care about that, I'm just going to do a finish pass. So I can take all that in one depth of cut. I'm fine with just doing a finish pass. So if I were to walk through step by step, FeatureCAM is wizard based, and so it'll give you suggestions along the way or make selections for you, which you can change and go from there. So right now you can see it's already picked a tool from my crib and calculated the feeds and speeds. However, if I want to go through and do my own choices, I can say, no, I'd rather this tool versus that one. So if I check the box, that would be the tool. I'm just going to go ahead and leave it at this. And based on whatever tool, then we get our feeds and speeds and any coolant we want to do. So the default settings are flood. So we see flood in all our features. If you didn't want to do that, you turn it off and choose something else, right? Or turn everything off. Okay, so then we can see a summary of what we did. We hit finish and we have our completed feature. And that is in setup 2. Okay, so now I know, as I mentioned, I need to basically machine these 2 channels and those flats. Okay, so I'm going to use a different form of feature recognition, which is called IFR instead of A. So the I means interactive, A means automatic, right? So what I'm going to do is go into features and choose a feature type that'll work. And I know I want a side feature because this is an open shape and an open shape through this channel. And then I got these flats. So I'm going to start with side. Now, if I did that, you'll see it wants a curve. Okay, I don't have a curve that'll work. So what I'm going to do is activate this feature recognition. So I'm going to extract it myself from the model using interactive feature recognition. So this is IFR. So I'll press next, and I could go in and pick the surfaces. So you'll notice right here the video is showing you what you need to do. Okay, or I could use this method if it made sense. Now this works better for closed shapes. You're like picking the floor of something. Or I could try one of these other methods. Now I typically only use one of the top 3. So I'm not going to get into all these right now. Maybe in a future video we'll cover all these. But I'm going to see what it will automatically find. And I'll hit next. And you'll see it found only the milling features, no holes. The slots it didn't find because I'm filtering out smaller cylinders with this setting. So you can see those are now active, but I have a filter on. Okay, this is already done, so I don't need it, right? So I only want to pick what I want to keep. So if I click here, you'll notice that that got the channel, and it's actually going to keep that tool in between those. That's great. Let me go over here and pick this one now. So I'm going to select that, and you'll notice it got the channel, but it also went around the perimeter, and that's going to help me get my flats. Well, that happened to work great. So this wasn't too hard at all. So I'm going to keep those features. FeatureCAM is going to automatically select tools, calculate the feeds and speeds based on my parameters, right? So try to use the 1/2" end mill, automatically pick something smaller, and you can see in this case it's 3/16, and then finish with that tool. Well, I could go in like before and say, hey, I just want you to use the 3/16, or maybe I want an 1/8" or something. And I can just set that and hit apply, and you'll see that changes that feature. I can do that also on the next one, just if I want. We all already know if the tool's too big, it's just going to skip it, skip that operation. You don't have to do this. Just a reminder of how you can change individual things up. So now I'm going to run this. In here, if I look at my operation list, this is the exact order things are going to run. These are following just a set of rules of minimizing tool changes. There are a few other things you can put in your automatic ordering that we see right here, or you can go manual and move things around. Okay, but you'll see there's a stop in here. And what that means is this is going to post both setups. So I need to have 2 vices or 2 sets of fixturing set up for this. And what I'll get is an M0 in my code. And it will say something to the effect of, flip the part and restart, something like that. You can have the message say whatever you want. You can edit that in the post, or can help you find ways to get it edited. That's something that can be offered as well, is post edits. So in here, I got my stop. And the reason for that is because in my settings for the file, it's an indexing setting. So indexing means 3, 4, or 5 axis. But you'll notice I'm not doing any multi-axis positioning. But there's a checkbox right here that says generate a single program with a program stop in between each setup. If I turn that off, now I'm going to only see which setup that I have active. So right there, I just clicked on setup 1. You'll notice there is no stop, there is no face 2 and side 6 and 7. They don't exist. Okay, if I click on setup 2, then it's that. So if you wanted to run a batch of them and then do another, then you could just post the code separately. But if you want to run them both at the same time, that's what this does. Okay, so now we have both. All right, so I'm going to run the simulation. I'm going to put a breakpoint right here. So I'm going to pause my simulation just after this stop by using a little breakpoint toggle. And that'll allow me to simulate everything up to this point. So then I can flip it over and show you the other side. Okay, so you'll see that it machined it. Now it's going really fast. Let me go ahead and start that over and slow this down just a hair. Okay, so here's our first setup. If we look on the left or the right side, we see the arrow. There we go. We're going to probably skip those 1/2-inch tools after this. There it goes. It jumped them. Okay, now there we are in the list. Working our way down. There's the program stop, and then there's my breakpoint toggle. So now I can rotate the part around, and as you can see, we're programming one part completely with multiple setups in this case. Okay, now the colors that you're seeing on the screen is something called tool colors. So every time we do a tool change, a color changes, and the area that it cuts is that same color. Okay, so this helps you to see where tool changes occur and see exactly what tool is cutting what part on, or what area on the part. Okay, so you can see that they basically contrast one another, so you can see the completed view. So there's a completed part. Here's the NC code, and if I scroll down here, here's the M0 triggered by that, and move part for the next setup and restart. So that post processor has it built in that when this is on, we output an M0. Oops. Close this, sorry. We output the M0 and put a comment. Okay, so that's a big overview of FeatureCAM. So let's look at feeds and speeds real quick one more time. So there are basically 4 pieces you have to have ready when you program. One is to pick the tool crib that you want. FeatureCAM comes with a few tool cribs. There's a basic, and if you install metric tooling as well, you'll get the basic metric. You'll also get the tools crib. So the basic crib is inch-only tooling up to 1 inch. There is a face mill that's larger that is in there. Everything else is 1 inch or less. Basic metric is 25 millimeters and below, except for the face mill. And the tools is a combination of those two, or if you did only inch-only tools, it's up to 2 inch instead of just 1 inch. So hundreds and hundreds of tools have been installed. Okay, so you get your tool crib picked, you select the post processor you need, and then when you start your new file, you load your configuration and say, hey, I'm going to make this out of stainless or something, right? Or 17.4 or one of these pre-configured things that you can set up. So all you have to do is go in and adjust about 10 or 12 settings from one material to the next, and you'll be good to go. The rest of the settings you can keep the same. But basically, we're talking about depth of cut, step over, pecking cycle types, and the peck amounts, things like that, right? So each one's going to be different based on what type of material. Then when you start your document, you choose what this is made of. So let's look at the feeds and speeds real quick. I'm just going to go to the top over here. Let me slide this up, and we'll just look at the face mill and this first operation. So we're 14 and 7 inch per minute, and then 593 and about 3,400. I'm going to change this material, and I'm going to go with something like aluminum. Okay, so I'm going to hit OK and hit OK, and you'll notice that those drastically sped up. So that doubled. This went faster. This went much faster based on the type of tooling that it is. So feeds and speeds change based on your stock properties. So what does that do as a benefit is it makes it so you don't have to make multiple copies of a tool with different feeds and speeds based on what you're machining. You just change the material and these settings will update. So we'll watch these top two, 130 and 14, and you see they changed a little bit depending on what we've picked. So those values, once again, come from the feed and speed table, which you can change any of these numbers at any time. If you want them to be more aggressive or less aggressive, that's totally up to you. These are just suggested values. So that is another piece of the puzzle, right? So the 4 pieces, once again, tool crib, post processor. What settings do you want? So you load them into the beginning. Those become the active attributes in your file. And then your material, what is it? And you're ready to go and program from there. So that's an overview of the FeatureCAM 2.5D milling, feature recognition we talked about, and also feature-based machining. So hopefully you learned a lot. We'll make more on these for turning and turn mill and 5-axis and things like that. We'll be making more videos in this series. So look forward to those. And thanks for joining us today, and have a good one.